Hello everyone, welcome to the first video of AAA Maths. The very first topic of mathematics B is mensuration. This topic is not the hardest topic at all, but most people find it the hardest topic. You know why? Because they cannot remember the formula. The main goal of this topic is you have to memorize all the formula regarding this topic. Without any further ado, let's start our today's video. So here you can see at the very beginning, the topic mensuration is categorized into two types of shapes. First is 2D shapes, the second is 3D shapes. So in today's video, we are going to talk about 2D shapes. So here in 2D shapes, we can see the two calculations which are required for each of these shapes are area and perimeter. Exactly, guys. These two calculations are mainly required for the 2D shapes. So at the very beginning, we can see the first 2D shape, which is called a circle. We are already aware of this from childhood. So this is the circle. So this is the center. So from here to here, I mean from center to the circumference. So this line is labeled as R. R stands for radius, and if you multiply R by 2, this becomes a diameter. So how will you calculate the area of the circle? Very simple. The area of the circle equals to pi r square, and perimeter of the circle is equals to basically the circumference, which is equals to 2 pi r. Hope you guys are clear. So the second 2D shape is semicircle. So semicircle is basically the half part of the circle, half part of this circle. But here this is also the radius, and if you multiply r by 2, so this becomes diameter. So, but here the semicircle's area is basically the half of the area of circle, therefore half pi r square. The circumference of the semicircle equals to half into 2 pi r, so that means pi r, and perimeter of the semicircle is basically circumference plus diameter, so therefore pi r plus 2 pi. The third 2D shape equals to sector. So there are two types of sectors, minor sector and major sector. So this is L1 and this is L2. L1 represents the minor arc length, L2 represents the major arc length. No matter which arc length you use, and no, no matter which sector you use, the arc lengths and areas formula remain same. So what is the arc length? Arc length equals to theta by 360 into 2 pi r, and area of any sector equals to theta by 360 into pi r square. So here theta equals to x, this is also equals to y, but make sure the calculator is set into degree mode. The theta x or y is basically in degree mode. So perimeter of the triangle, so perimeter of the sector equals to 2r plus L1, and this is also equals to 2r plus L2. The uh, formula same but calculations answer is different. So now next we have segment. So here, you can see the blue parts of the shape. This is what we call segment. So this is the length L1, which is equals to arc length 1. And so this is a sector. This is also a sector. This L2 equals to arc length 2. So you might be having a question that why these two labels are different? Because both arc lengths may not have the same value. That's why. The area of the segment equals to area of sector minus area of triangle, and perimeter equals to L1 plus A2. It is also equals to L2 plus CB and AB. And so what's the area of triangle? We will get to know further. So next we have is a triangle. So here you can see the triangle. So there are three types of triangles. First is scalene triangle, second is isosceles triangle, and the third is equilateral triangle. So first we have the scalene triangle. So in scalene triangle, the three sides are of different length. Same goes for three interior angles. Those three of them are different. So and in isosceles triangle, you can see both sides are equal and other side is different. So similarly, angles are these two angles are same and this angle is different. And we have equilateral triangle. this is always fixed that the interior angle is always equals to 60 degree, and each interior angle is always equals to 60 degree, and sides are of equal length. So area of any of these triangles, so no matter area of these triangles, no matter which triangle is, say it's always equals to half into AB into AC sine theta 1 is equals also equals to half into AB into BC sine theta 2. It is also equals to half into AC into BC sine theta 3. So here, no matter which formula you use, the answer will be same. So, and which length you will multiply, it mainly depends on which angle you choose. So if you choose theta 1, so you have to multiply the sides of AB and AC. If you multiply theta, I mean if you use theta 2, then you have to multiply the sides of AB and BC. And if you select theta 3, so you have to multiply the sides of AC and BC. So hope you guys are clear. Now the another triangle we have is a right angle triangle. So here you can say right angle triangle. This is D is obviously perpendicular to EF. Here you can see, and this triangle, uh, where most people make this mistake that the perpendicular head is basically from here to somewhere here, but no, actually the perpendicular head is from here to here. So hope you guys are clear. So now area of this triangle, area of right angle triangle, no matter if it's this or this. If you know the height, then you obviously you can use this formula, which is half into base into height. And perimeter of any of these five triangles equals to sum of all three sides. Nothing. So I hope you guys are clear about the triangles. So next we have is quadrilaterals. Here quadrilateral is the word quadrilateral is divided into two parts. First is quad, which means four-sided, and the second is lateral, which means figure or shape. So here you can see that. And so in general, quadrilateral means what? Four-sided figure or four-sided shape. So, so this is what quadrilaterals mean. So now so here it is written that there are six types of quadrilaterals that are given below. The first you can see is a square. So here this is a square. We have seen this from childhood. Here the four sides are of equal length. Therefore, area of the square equals to L square and perimeter equals to 4 into L. The second we have is rectangle. So this is the rectangle. We have also seen this from childhood, and this is very quite similar to square, but not all sides are of equal length. AB and DC they are of equal lengths, but AD and BC they are also of equal lengths, but and to each other. So therefore, area of a rectangle equals length into breadth. Here L into B, and perimeter equals to double L plus double B. Yeah. The third shape we have is a rhombus. So here you can see a rhombus. Here all sides are of equal length, and if we draw two diagonals, the angle between a diagonal equals to 90 degree. Here perpendicular line, you can see that. And yes, whenever you go to solve a question regarding rhombus, don't forget to put this mark to put this marks here. Here equal signs over each line, you can see, and don't forget to draw the diagonals, and don't forget to give this perpendicular line, or else you will lose mark. You got it. Be careful, guys. Okay, so here this is in the rhombus. I told you about the area of the rhombus equals to half of d1 into d2. Here d1 d2 represents diagonals, and perimeter equals to 4 into x. And is similar to square, right? Obvious, the perimeter, not the area. Okay, now let's move on to parallelogram. Here you can see this is a parallelogram. It's quite similar to rhombus. Hmm. And similar to rhombus, here AD is parallel to BC and AB is parallel to DC. and this is the perpendicular height from here to here. And okay, so the area of the parallelogram equals to base into height. This is the base and this is the height, and perimeter for the parallelogram equals to 2 times x plus y. The next we have is a trapezium. Here you can see this trapezium. Here AB and DC are parallel to each other, and this is the perpendicular height from here to here. The area for the trapezium equals the half of the sum of the two parallel sides, therefore m plus n, then into perpendicular height. And the perimeter for the trapezium equals to sum of all four sides of the trapezium, nothing else. And the last quadrilateral we have is a kite. Kite we have flown kite high up in the sky during our childhood and in these age as well, no doubt. And anyways, here here AB and AD are of equal length, here length C, and BC and BD are of equal length D. And area for the kite equals to half into D1 into D2. Here D1 and D2 represents diagonals, and perimeter equals to 2 times C plus D. So hope you guys are clear. So now next we have is a summary one. So before that, you might be having a question that why did I put this asterisk? You might have seen this asterisk somewhere else. Where is it? Here before the words perimeter and area for each of the 2D shapes. That's right, guys. So the reason to give this asterisk is written in summary one. So let's see what the summary one say. It says that each of the 2D shapes mm, has their fixed formula for area, but no fixed formula for perimeter. As perimeter equals to sum of all lengths of boundary sides only. Exactly, guys. Please keep this in your mind. These two notes. Well, never forget that. That area has their own formula, but no formula for the fixed shape. I mean, no fixed formula for the perimeter. Mainly, the definition for the perimeter is the formula for 2D shapes. Please keep that in mind. Don't forget that. So that is it for today, guys. I hope you guys appreciate my work. If you really did, please hit the like button of this video and do not forget to subscribe my YouTube channel. And I will see you guys in the next video. Thank you, everyone.